All right, let's get a few more things shuffled around here. Looks like got sound into OBS at least. So otherwise it shows like it. All right. And let me turn off this preview. Okay. All right. This one too. Okay. All right. Jumping straight in tonight. So I'm actually picking up where I left off. If anybody watched the latter part of the previous stream from Tuesday, maybe Tuesday evening. We started working on this, which is a PR that KMatch did to CircuitPython core. There's a little video that demos here. Basically, this is allowing you to split the REPL, well, the serial output, the terminal on the screen that represents the serial output, and have a separate section of the display that is a DisplayIO area, right? Like a DisplayIO canvas. We can draw things up there. And so this is in now. The other day, we built it, and there was actually an unrelated issue with the PyPortal, which was already resolved. I just needed to merge main, but I didn't know that at the time, and so we didn't get this working the other day, but it is working now, and not only is it working, you don't have to build it yourself anymore. So anybody could actually do this if anyone wants to play around with this functionality. So that is what I am trying to do tonight. I think is going to be just play with this some, and I don't have a specific like thing I'm trying to build with it in mind. I want to play with it some. I want to use it to maybe talk about the basics of DisplayIO, maybe talk about the basics of display text, and just play around with it, honestly. So that is what I'm going to do. Ultimately, I think it would be great to make some like introductory or some like how-to content around these things, around DisplayIO and display text, and maybe even around the different widgets, the different libraries that exist, some of the newer widgets that we've created. I think we could do some kind of like how-to videos around that stuff. So I'm like playing around with those ideas. I'm not necessarily recording that, right here today, but I am kind of playing around with stuff that may end up used in that capacity. So I am going to update CircuitPython. You could probably see there I was downloading the latest build from S3. So since this is merged in now, I think we should be able to use this latest build. The build I have on my PyPortal right now does work, but whoa, it's one that I built after I merged main to the branch, and this one will be like an official build. At least I thought it was. Maybe I changed it at some point. That doesn't say dirty like it normally would if we had built it. I'm not sure. Anyway, though, this is the latest one, so we'll use it. Copy. What are you doing, buddy? Oh, I was chasing around a mouse, I see. Stuffed mouse. Alright, so this is going to be updated. So, for anybody who doesn't necessarily know yet, this thing that KMatch has done, let's close some of this stuff, we don't need it right now. Where did this one? Yeah, this is the one we want. So this PR allows you to split these two things up, the terminal output and the DisplayIO canvas, and there is a basic demo of this on the PR page, so this is a good place to start for anybody who is interested in this new feature. I also have this here, which I kind of cut a little bit out of the sample that KMatch left there and made this into like a REPL sort of helper command, helper function type thing. So I basically have screensplitter.py. It has the single function screen split. You pass it in the display, and then it does a couple of things. It shrinks the terminal. It moves the terminal to the bottom half of the screen. It creates a new group, DisplayIO group, that you can then start adding things to. And it shows the new DisplayIO group by adding it, by adding the terminal to it, by adding the root group. Yeah, the root group, which is like the systems group, goes into the splash. Okay, then the splash goes into my group, and then my group ultimately is what gets returned. This is all like cutting edge stuff. I just kind of whipped this up when I played with this last night. And the PR just got merged yesterday or the day before, I think, so this is all brand new stuff. But basically what this means is you can use this from the REPL. So we have the terminal here. Terminal is loaded up to serial. So we are in the REPL on the PyPortal. One thing is it's set to landscape right now, right? It's 90 degrees different. So we can actually pretty easily just go import board, and then board.display.rotation, lowercase rotation, but uppercase display, equals, I think this is 270, but it would be like 90, 270, 180, or 0, right? Those are the 4 orientations. So we guessed it right. Blinka's up here now, and she is the right orientation. And so for anybody who's new to the REPL, the REPL will print on the screen as well. So like while I'm typing things here, like as I'm typing print like this, it's showing whatever I type onto the screen right there, right? Which is really cool. And then eventually, whenever we actually do print something, it will also print that into the serial as well. So this is like the very foundation of the CircuitPython REPL. But in the past, it was not necessarily, it was not as friendly as it is now to work with the REPL and DisplayIO, because the deal is you either, in the past, so, before yesterday, you had this display, which is showing the serial output, everything that prints in the REPL, all of that sort of stuff. You can either show this, or you can show a DisplayIO group. Or a single DisplayIO element as well. Oftentimes it would be a group. So, oftentimes your code would do something like this. You would make a group, let's say main group equals, so we didn't actually import. I'm going to need to do that. You know what, let's keep it in the REPL. I want to play in the REPL. So, we won't be able to copy paste the code as much, and we can't necessarily reuse it. But I kind of want to play in the REPL a lot. So let's go import DisplayIO. Now we can make a group. Main group equals a DisplayIO group. We don't have to pass it anything. Well, all the default parameters are fine. We can display it right now. There won't be anything to see, but what we will notice is that this will go away. So if we go board.display.show main group, now we have nothing showing here. We have a completely dark screen. We no longer see, if I start printing a new thing, if I start typing a new thing into here, we no longer see this on the screen, because now the screen is showing main group, and it is no longer showing the serial terminal IO, which is what the widget that shows all of the text there in the terminal is. So this used to be either or. Now we can do both, though. I will show you, I guess let's add something to this. Since we don't have anything here, let's actually show that this is showing something, right? So let's say one of the most basic things you could do with DisplayIO is show bitmaps. Honestly, DisplayIO is mostly based around bitmap graphics. And when I say bitmap, I mean, generally speaking, a two-dimensional pixel, two-dimensional array of pixels. Each pixel stores an integer. The integer maps to a color using a palette. There's a couple of different moving pieces to make all of that work, but that is kind of like the core of what you can show with DisplayIO. And then there are some clever things built on top of it to make it, more useful at a higher level. But the most basic, you can just use a bitmap. So we can create a bitmap by just going bitmap equals DisplayIO.bitmap. I think we probably have to pass it a few things, maybe like width and height and the number of colors. That's my guess, but I'm not actually 100% certain. So what we'll do is we'll go bitmap docs, CircuitPython, we'll just pull up the docs page as well. Nope, this is Bitmap Tools, which there's lots of cool stuff in there. We will get to there eventually as well. That's another thing where we could use a, can't just have bitmap like DisplayIO bitmap. DisplayIO.bitmap. There we go. Width, height, value count. So we probably want all three of those. So let's say we want our bitmap to be 100 pixels by 100 pixels, 100 by 100. Let's say we want to have the most basic bitmap would just have, would it have 2 or 1? I think it would just have 1 color, which then begs the question, like, what's the opposite color? But I think in this case the opposite is just off, no color. So we can give our bitmap 1 color. We have a bitmap now. In order to show it on the display, what we need to do is add it to our group, which we previously called, show on our group. So we need to get our bitmap into our group, but we can't just add it directly, right? You might think main group dot append bitmap, but no, we need it to be a group or a tile grid. So we have to have either, those are the only two things that we can add to a group, is another group or a tile grid, which ultimately means, the only thing that we can add to a group that in and of itself shows something is a tile grid. A group doesn't in and of itself show anything. It shows all the things that are contained within it, but like it's a container. It's not actually showing, depending on how you think about it, it's not actually showing the things. A tile grid, though, tile grid actually does show things. This tile grid, basically, I think of it as a few different things. One of them being a map between basically the thing that connects together a bitmap with its colors. A tile grid brings together a palette of colors, and a bitmap connects them together, and the resulting thing you're then ready to draw onto the screen. So let's make one, tile grid. Tile grid, I'll just make it tile grid like this, equals, this is in DisplayIO, DisplayIO tile grid. What do we have for default properties here? I think, what do we need to pass? Tile grid. Right, so we definitely need our bitmap, and we need our palette. So we should have probably made a palette before we did this. So here's what I'm going to do actually is copy this, and we will get back to it in a minute. We need a palette, so we're going to go palette equals, this is also in DisplayIO, palette, and this one we need to tell it how many colors it can have. So we chose 1 color here on our bitmap, so we should choose 1 color here on our palette as well. Those should match. We can set the color, so palette functions sort of like a list from the Python perspective. You go square brackets, you get an index, and then you set a color to it. So equals 0x, what color do we want? Let's go pink. Okay. Now we have a palette, so we can go back to our tile grid. So we need to give it the bitmap and the palette, which the argument name is pixel shader, but you can see here it can either be a palette or a color converter, which is kind of like a built-in type of palette that you use sometimes. So our bitmap is just called bitmap. Pixel shader. You know what would be nice? I don't think these don't do autocomplete. This is one thing maybe that would be really nice in the REPL if it would autocomplete arguments. I have no idea how the REPL autocomplete even works, but that would be super cool. Pixel shader equals palette. DisplayIO, I probably spelled wrong. There we go. So now we have a tile grid, and again, that's connecting together our bitmap and our palette. We brought those two things together, and now we can add it to the group, which means that we can show it on the display. So let's go, well, let's add something to it first. So let's say we want to manipulate now our bitmap. Our bitmap is 100 by 100 pixels, and we can either basically have a color at a certain pixel or not. And the way that we set which pixels do have colors is by going bitmap, well, one of the ways. We can access it. Let's see, I think, do we do as a tuple or do we do XY separately? Let's get back to bitmap. So a lot of this stuff I know about, but I tend to copy paste code a lot more than I do just write it from hand like this. Bitmap. Up. Bitmap. Tuple. Well, we don't even have to actually make it a tuple with parentheses, but we put our parameters in commas like this. Let's go back to here. Bitmap. So let's say we want to set the pixel at 20 pixels x by 20 pixels y, and we want to set it. In this case, we only have one color, so we can set this, I guess, to 1, or do we set it to a 0? It seems like that worked. It seems like 0 maybe would be what we want. I guess both of these are going to work. Too many bits. Okay. Yeah, I think this is a thing, though, where it doesn't necessarily cap you at the right color. Anyway, though, one thing is we can see so far we'd expect this would fill in a pixel somewhere on our display because we're changing this. I don't actually know if it's a 0 or a 1 that is going to make it actually show off the top of my head, but I tried both of them and we're not seeing the pixel in there. And the reason why is because we didn't add it to the group yet. So let's do that, because we have our tile grid. It combined together our bitmap and our palette, but the group that is showing currently is main group, and we've not added tile grid to it yet. So let's do that. Main group dot append tile grid. Now it's there. Okay, so right away we notice a change. We have pink everywhere, and it actually looks like it's opposite. So we set our 1 pixel. What is the most recent one we set it to? We set it to 0, and that actually made it black. So we actually have this 100 by 100 square of pink, and then we have one tiny little black pixel there, which is probably hard to see, but it is there. We could make it a little bit bigger by, oh no, we set it to 1 most recently, which I think is probably making it black because it's outside the range of our palette, honestly. Our palette only has 1 color, which means it only has index 0. I think the way that we're setting this to 1 is technically overflowing the palette and then maybe just defaulting back to 0? Like the color black 0, though, I mean, not the index 0, which in our case is pink. That's probably what's happening. So really, I guess it's more frequently that you would probably have a bitmap that is 2 colors, although I guess you can use this like it's 2 colors as long as one of your 2 colors is black. So let's say we made pixel at 21 also, and let's just do a few here. So you can see it's starting to get a little bigger. Are black. Now it's like a 2 by 2 section, 2 by 2 pixels of black. So we have 4 total pixels now. And we can do things fancier, like we could make a for loop, right? For Let's say for I in range 30. And then inside of here, let's do another for loop. So maybe I should have called these X and Y. Is it too late to change it? Yeah, I think so. Yeah. So actually, let's just do the one for loop for now. So let's go another, so for, no, not another for, but let's go bitmap. Let's draw a vertical line. So if we want to draw a vertical line, we are going to choose a static X position. So let's say we're going to draw it at pixel 40. We're going to say 10 plus I. So that pixel we are going to then set to 1, which we've seen before is turning our pixels off. It's setting them to black. Do this, and now we have a black line drawn here. Anyway, before we play too much further, though, I want to get to the split screen. So, we're typing into the REPL here. We're not seeing it on the display. The new thing we have is the ability to actually do both. So I created this group here. I added the most basic thing, a bitmap. I showed how we can manipulate some of the pixels on the bitmap. But let's go and get into split screen land, and then we'll pick it up back here and play with the bitmap some more. So in order to do this, we just go... should I restart the REPL? Yeah, let's restart the REPL. I'll do Control C. See again. So we go from screen splitter import split screen. Nope, no parentheses yet. And now we want to call it split screen, but we do need to actually go import board, and then we can call it split screen board.display. There we go. So now we can see Blinka is down here. And what has actually happened here is we have split the display in half. We have the terminal on the bottom half, and we actually have a DisplayIO group on the top half. Which actually we should have caught into a variable, which I forgot to do. What happens if we just run it again? Let's say DisplayIO group equals. Let's just try this again. I don't know if you can call it 2 in a row, if that's bad. I think it resets itself with display.show none. Okay, so DisplayIO group we have. So let's make a couple of those things again. Import, I'm gonna go actually from DisplayIO, import bitmap, tilegrid, palette. Okay, bitmap. I'll do 100 by 100 again. I'm gonna do 2 color. I think this is probably the more proper way to do it. Even if you want a 1 color thing that's either like pink or black, which is really kind of technically 1 color, I think setting this to 2 might be the more proper way to do it. I think the way we were using 1 before is kind of relying on the bitmap not checking the actual maximum size of the palette. So let's do 2. Let's make our bitmap. Let's make our palette. Palette. I'm going to do 2 in the palette as well. And here we're going to go and actually set 0 to black. This is going to end up doing kind of mostly the same thing as before. But we're just not relying on that weird quirk of bitmap not checking. So we'll have, let's do black and green for our 2 colors right now. And let's make a tile grid. This time I imported them from DisplayIO so I can use them directly instead of putting DisplayIO dot tile grid. So this is going to be our bitmap. And our palette, can we just do palette as a positional? No. Oh, okay, maybe. Let's see. Extra positional, no, okay. So this is pixel shader. And now we got it. So now we have, back here, we caught DisplayIO group. We called split screen, and we caught DisplayIO group into a variable, and that is now the group that is on the top half of the display. So if I go DisplayIO group dot append file grid, this is now showing up here, but in this case, we don't see anything because it is all black, but we can now do the same kind of stuff as before. We can go bitmap, choose a pixel, so let's say 4040 equals 1, and this time it made a green pixel right here. Again, it's very small, so let's make something bigger for X in range, let's say 20, for Y in range 20. Bitmap, let's say 50, 20, and then we're gonna go plus X plus Y equals 1. So basically we're making a square right here, 20 pixel by 20 pixel square. By counting our two for loops up to 20 and then adding whatever one we're on. Are we making a square or are we making a diagonal line? We might be making a diagonal line. No, we made a square. Okay. Second guessed myself. Because we have an inner for loop. So really what we did is we made a series of columns. We made a bunch of columns, one after the other. Because we would have ran this this inner loop 20 times for the outer loop, and the inner loop is setting a pixel and then moving Y with its for loop. So it's drawing vertically a column, and then it would, when it's done with one column, jump to the next one, which was in this top for loop. So you can see, though, it made a big green, well, medium, small, really. It's bigger than 1 pixel, obviously, but, you know, medium size, 20 by 20 pixel square there. But there are other things we can do with a bitmap, like bitmap.fill. You can set the whole thing to a single color. So remember, we made our bitmap 100 by 100. I can fill the whole thing with green. What else can we do with a bitmap? Is there a draw line, or am I thinking of... So there's blit. This will basically cut part of one bitmap and put it into another. We only have one right now, so we don't have an easy way to show it. I think I'm thinking of Bitmap Tools, which is worth looking at while we're still here in the bitmap pixel stage. So let's start looking at Bitmap Tools. Let me open a separate one of these. Bitmap Tools. Okay, Bitmap Tools. So there are a couple of things in Bitmap Tools. Generally speaking, though, these are functions that manipulate bitmaps for you in various different ways. Some of them we're not going to use right now. Some of them we will. Rotozoom. This is kind of like blitting, but it also gives you the ability, so it's like cutting from one bitmap into another, but it also gives you the ability to clip and scale, I think, as well. Maybe do some other manipulation. Alpha Blend. I have not played with this one yet, actually. I mean, I've been meaning to play with this one. This is a new one I think Jepler did while he was working on cameras. This is blending two bitmaps together. Fill region. Okay, so fill region would give us another easy way to make a box like we just did. So let's do that. Let's get our back to here, and let's go from bitmap tools import fill region. And let's see, it takes destination bitmap, and then XY x1, y1, x2, y2, and then the value we want to fill in. Let's plug in those values. Fill, whoops. So a lot of these, the way they will work is you'll call the function and you'll pass the bitmap or bitmaps if there's multiples that you are using. So ours is just called bitmap. X1, Y1. So we already are currently filled green. Let's make a black box by setting it to 1. No, setting it to 0 when we get there. But let's say we want to make a box that's bigger than last time. Let's say we want it to be 40 pixels by 40 pixels. So we choose a start point, 2020, and then we choose a end point diagonally away from it. Let's make it not a square, actually. Let's make it, so let's say 40 pixels wide by 30 pixels tall. And then we give it the index we want to fill with, which in our case we're going to do 0, so that it makes black. We have this black cut out now. So fill region. This is another way that you can make rectangular shapes in your bitmaps, and you can do it with any color. Right now we're working with like a single color or technically a 2-color bitmap, but all of these same concepts are going to apply for a more complex one as well with more different colors. Should make some. Oh yeah, I need to. I'm gonna stop now and go make them. Yeah, sidetracked thinking about cookies. Thank you for the reminder though. Definitely want to. I have some dark chocolate kisses that are set aside for these. I'm super stoked about the dark chocolate ones. Fill region. So what else do we have? There's some more fun things in Bitmap Tools. Fill region. Boundary fill. Boundary fill is actually near and dear to my heart because this is basically the first like real contribution to core CircuitPython that I made. This is kind of like the paint bucket in fill programs. You can select a pixel and select a color, and it will like grow outwards from that pixel and fill in everything it touches. But right now, since we don't have any more interesting shapes than a box, it won't really do a whole lot for us. We could fill this box back in, but we could also fill this box back in by just drawing a box again. There's a couple of ways we could fill the box in. And boundary fill, not the most interesting. Once we have some more convoluted shapes, though, boundary fill is really nice because we can fill it in. So, like, if you want to fill in a circle, or if you want to fill in an arc, or an oval, or something like that, you can fill it in with boundary fill. Draw a line. Here we go. This one we can do. We do the 2 points again, and then we do the color again. So this actually has basically the same signature as fill region did. Draw a line. So let's draw a diagonal. Let's make an X in our box here. So we're going to go bitmap. We're going to go top left corner, 2020. Bottom right corner. So that's the same as this one, actually. Bottom right corner. I'm going to do 1, though, because we want it to be green. Draw a line again. This time we're going top right, so 60. And then bottom left, 20. $2050? Yeah, I guess so. 2050. Yeah. Okay. So now we have an X in the box that we cut out previously. Draw a line. So this is a nice one. If you're doing basic charts and graphs or something like that, you can make use of draw line function. You You could use it to draw shapes, like polygon shapes. If you had a list of points or something, you could draw lines between the points. And then you could use the boundary fill to fill inside of it. So you could make like a trapezoid or a rhombus and then fill inside of it using the boundary fill. Let's do that. Let's do that. So actually, let's start by going bitmap fill 0 back to empty. Now let's draw a couple lines. First line 2020 to 60 20. Okay. Second line from 6020, where we just left off, to 100. Well, 99, I guess, is the edge of our bitmap. So we have a 100 pixel bitmap and 0 is the first index. Let's say 99, and then I want to go down some, so let's say 40. So this will draw a diagonal down. There we go. Now let's come back some. We're going to go from 9940, where we just left off, to 90, no, to, let's say, 99 minus 40, 54, no, 50, 59, 99 minus 40, 59, yeah, I think so, and then y 40, horizontal line, 40 pixels back to the left. Here we go. And now the diagonal. So closing it off, we're going to go from 59, 40 to the point we started on, which was 2020. 2020. Okay, so now we have an oblong, I think it's a rhombus, maybe technically, I don't know for sure. We have a diamond-y looking thing, a squashed box, depending on what you want to call it. I am not a geometrical expert, but I recognize a squashed square when I see one. And that's what we have. And so right now, you know, let's say we wanted to fill this in. It's kind of tough because we can't just draw a box inside of it. Because of the diagonal edges, it's an irregular shape. I don't know if that's technically true, if that shape is actually used, that term I should say. If irregular shape, I don't know if that's a term used. That might be a real term in geometry and it might not apply to this. But what I mean when I say it is just it's not a square. We can't fill it in by just painting a box of pixels. We need to paint something more complex because of the diagonal lines, which this is where boundary fill actually shines. So we can say, let's get boundary fill. Whoa, what was that? Boundary fill. And what do we take here? So we're going to take the bitmap again, I'm sure. Bitmap. I don't remember the order. Is it... We'll need to pass a point, so XY and then a color? XY, color value, and a replaced color value. Do we need all four, or can we do 3? So we want to pick a point that's inside of our diamond. So let's say we came down from this point here, we would be pretty much in the middle. And this point is 60-20. So if we say 60, 60-30, or like 25, we should certainly be inside at 25. Fill color, we want to fill it with 1. I'm going to try it like this. Yeah, that worked. Now we have the filled in rhombus. You can send the fourth parameter, and the fourth parameter basically means only replace pixels that are this color. So in our case, we could have given it, well, not this color, but rather this index, because the bitmap by itself doesn't know about the colors, right? It only knows the index of the color within the palette. To hammer that point home, let's say we have a green diamond now. Let's say we want to make it red. What would we do if we wanted to make this diamond red? We could, go make another bitmap. We could make another palette, make another tile grid. We could append it. Then we could have 2 diamonds and one could be red. But is there a way we can just turn this diamond right here red? And we can. We can just manipulate the palette. We have this palette object here. 0 index is black. 1 index currently is green. We can just change this on the fly. Palette 1 equals, let's make it red. Boom, turned it red. Make it pink. Make it blue. So this is one thing that's actually can be used as a nifty efficiency trick. Who was it that taught me this? Was this I want to say this was either Marius or David Glauda, but I don't remember for sure which. Maybe both at different times. I don't know for sure. But this is actually kind of an interesting efficiency trick, because changing the color in the palette can be done quicker than changing the pixels in the bitmap sometimes. So like, let's see. Let's imagine, so we actually have 2 colors in our palette. Let's make palette 0. Let's change palette 0 to pink. Okay, so in our case, that turns the whole background to pink. So if you wanted to, really this example would make more sense with more colors in the mix than just 2, I guess. Yeah, I think so. Yeah. Okay. Skip that for now, I think. Teal. Palette 1. Makes an interesting looking outline on the screen, but it's not actually, when I look at the actual PyPotter screen, it doesn't appear that way. That's just kind of a trick of the camera, I guess. Anyway, though, keep this in mind. If you need to change the color of something, you have a couple of ways you can do it, especially if you have a bitmap with more colors in it. If you had a bitmap with 10 colors or 100 colors or something, and you have a part of it that's green and you want to change it to red or whatever, you might be able to flip the palette, flip the colors in the palette, which may end up being quicker than trying to replace like green pixels with red pixels, for instance. What else do we have in Bitmap Tools? So we saw draw line, we saw boundary fill, fill region, ArrayBlit. So this is helpful with Microlab, I think. Let's just have a dark mode that I can do, or I guess do I get that from an add-on? I guess I'm in dark mode and it's just not doing this page. of like dark mode. Oh jeez, that's not what I meant to do. So I turned it off. Sorry, we're just gonna jump to Chrome here so I can have a darker one of these box pages. There we go. This is a little nicer on my eyes this time of day. Okay, so this is DisplayIO. So let's see, what all, we haven't done roto zoom. We need a more, well, we don't need a more complex bitmap, but it is probably going to make more sense with a more complex bitmap. Boundary fill, draw line, we did ArrayBlit. This is where we left off. So ArrayBlit, this basically takes the data that's contained in an array, moves it over to the pixels. So if you crunch a bunch of numbers, like if you read a bunch of numbers from a sensor, let's say, and you crunch them with ULab somehow, MicroLab, you run a bunch of calculations and get a bunch of outputs, a bunch of data samples or something like that. You can store those in an array and then quickly bring that array into a bitmap to visualize it, basically make a graph out of it, visually speaking. I've never actually used it. Insert pixels from data into the rectangle of width and height pixels, the upper left corner. X and Y are not specified. They're taken as 0. So basically, in our case, this would plot the two different colors we have. But this is also probably a thing that would make sense with more data, with more colors to make more data points. Read into, it's from a binary file into a bitmap. So this, what is this one? This is is this a native implementation of image load, basically? Well, it's not creating a new bitmap. It's reading a bitmap file into an existing bitmap object. I guess is actually a little bit different than image load, which I think is creating a new bitmap for you from an image file, a bitmap file. This is like you could have a buffer that's a certain size bitmap object, and then you could like read one file into it, and then at a later point read a different file into it by calling this function 2 different times. And so you would only keep one bitmap in memory, but be able to show those 2 different things. I haven't messed with this one too much. I think it's used internally by a couple of the DisplayIO libraries, though. I remember doing something in a library with it. Dither. This is another one of the new ones. I haven't played with Dither either. Okay. So we looked at a few from Bitmap Tools. We didn't get 100% of everything. Got to run Cedar. Thanks for the stream. We'll watch the rerun later. Yeah, thanks. Thanks for hanging out. So let's play with something else. Let's look back into DisplayIO. There's a couple other things that we can do. Some of them are even a little more, I won't call them hidden, but less well known, certainly. Let's look at DisplayIO shape. DisplayIO shape. This is another way that we can draw boxes, but it can also do some more fancy things than just regular boxes. Let's make a shape. Let's see, where is... I was thinking there was some sample code there. You know where I started putting sample code that might include this is CircuitPython sample code module examples. DisplayIO shape. Yeah. Start here. All right, so let's, so shape is its own thing. Everything we've done so far is all manipulate pixels that are inside of a bitmap. But shape is a different kind of thing. So let's do it. Shape is like bitmap, but it's a little bit smarter than just a regular bitmap. A regular bitmap is a two-dimensional array of indexes, basically a two-dimensional array of numbers. Shape ultimately boils down to that, but has a couple extra features like mirror X and mirror Y, which allow you to do some interesting things that are the same on both sides and save a little bit of memory. That may not make sense, but we'll look at a visual example when we get to there. But to start with, let's just make a basic shape, which is going to seem like a bitmap when we first do it, because it's going to draw a box. That's basically what shape can do, is draw a box, a rectangle, I should say. It doesn't have to be square. It can be, you know, wider than it is long or longer than it is wide, which also makes it good for doing things like drawing a, you know, a line, like a divider line. If you want a divider line that's 1 pixel tall or 2 pixels or whatever, shape can do that for you, so that's a good usage of it as well. Before I dive into shape, though, actually, give me 1 second. I'm going to run and switch the laundry real quick. And we're back. I also went to fill up my water. So shape draws a rectangle, basically. Put the code in for it. So we need, those would probably default to false, I would assume, but I guess we'll find out. Well, we could see in the docs, actually, right? Shape, we're already there, should we? Yeah, these default to false. All right, so for a shape, we need a height and a width, and then a just a color. Well, no. The color still comes from a palette. We need a height and a width, and actually, that's going to be it. So shape. I'm going to make a. Well, we can do it before or after. It doesn't really matter. But I'm going to make another palette. I'm going to call this shape palette. Doesn't really matter the name. Equals palette. I'm going to make the shape palette. We want it to be two colors. Basically, shapes have a foreground and a background. That's how I think of them. I don't know if they actually use that terminology in the docs. No. Doesn't. Doesn't really call the two. It calls it one bit, which in this case is like either a 1 or a 0, which means we have two values, we have two colors. I think of them as foreground and background, personally. Shape palette, I'm going to make it 2, so then we can go shape palette 0, so first index equals, let's make it blue. And shape palette 1, let's make it red. Whoops. Okay. Now let's make a shape. Shape equals, oh, I didn't actually import that. From DisplayIO, import shape. Shape equals a new shape. Width and height, let's call it, so what do we have total? We have 240 for our whole width. Let's go half of that, 120. And let's make it rectangular. So let's go 120 and 60. And we'll just use those as the defaults. And now shapes are kind of like bitmaps in that you need to tie them together to a palette in order to show them on a display. And the thing we do that is actually a tile grid. So earlier I said a tile grid was a way to tie a bitmap to a palette. It also works for shapes. So more generally, a tile grid is a way to tie a DisplayIO object to a palette. Works with shape. It also works with bitmap like we saw before. So we need a new tile grid. So I'm going to say shape. I'm going to call it just shape TG for tile grid equals tile grid. Tile grid. We give it the shape this time, shape, and then we give it the pixel shader again. Shape palette. There we go. And now we should be ready to just add it to the group. So we can actually say DisplayIO group, which we created earlier, and it got passed to us back by the split screen thing. That's our group that represents the top half. Dot append the shape tile grid. Whoops. Whoa. Okay. There we go. That is our currently red rectangle. Let's move it. We haven't talked about moving things. We drew pixels at a different location inside of our bitmap, but at this point we have not actually talked about moving things. So anything that is a tile grid has an X and a Y. So we can go shape tg.x equals 30. And this is going to scoot that thing over by 30 pixels. We can go y equals 30 also, and that's going to scoot it down by 30 pixels. We can make the x even higher, like 110. And it will scoot it all the way over there past the bitmap. So this is how we can move things around. So I said earlier that shapes had two colors, and we only have a red rectangle. So what's up with that? How do we get our second color? With Bitmap, we color in colors by setting a pixel at an XY coordinate, and we give it the index of the color. With Shape, it's totally different. We set what are called boundaries. And we set the boundaries by calling setBoundary, and we pass them, I think, two numbers. Yeah, a start and an end, a start X and an end X, and a Y. Right, so we actually pass it three values: the Y, the start X, and the end X. So basically, we are declaring certain rows. We declare a whole row at once, and we declare which part of the row is in the foreground and it is in the background. This is the way I think about it, at least. So let's do one to start with. Shape set boundary. So Y, let's just start with the first pixel, 0. And then let's do the whole thing. So let's start on 0 and go up to 120, or I guess 119? X value out of bounds, 119. There we go. Set boundary 119. So I think nothing actually changed. And so maybe that's because we set it to the whole thing, and maybe the boundary is the part that draws red. So let's actually try smaller now. Set the boundary instead of 100, instead of the whole thing, basically. Let's say we want to do the boundary 50 to 70 or 80. There we go. Now you can see, well, maybe you can see, they're a little bit tough because there is only one pixel so far, but there's a couple of blue lines here now on the top. Let's do the same boundary, the next pixel down, and the next pixel down, and one more. So we've set the first 4 rows now to have boundaries. We could do a few more of these and have flag of something, Denmark? I'm probably wrong. So basically, we're setting the boundaries of where the foreground color begins and ends. The way I think about it is the blue being the background color and the red being the foreground color. And when I'm setting boundaries, I'm basically bounding where the foreground is going to begin. And we set them one row at a time. As you can see, we declare the Y value of the row that we want to set currently, and then we declare the beginning of the boundary in pixels. So like we did this, this area right here was our 50, and then the end of the boundary, which is our 80 over here. Everything inside of that will be considered foreground, so it will get set to, in our case, red, which is 0 on our palette, and everything outside of that bounds, everything below 50 and above 80, will get set to index 1 in our palette, which in our case was blue. So that's the sections here. So it's kind of a weird, like interesting, weird way to interact with it. It's like a bitmap, but not exactly. It's kind of got this extra sort of logic built into it for you to quickly and easily fill in different chunks. And then something else that's really neat is the way that it can be mirrored. Let's make a new one. Let's make another one that's smaller. Let's talk about removing. We haven't removed anything from the display yet. We've added a couple of things, but we've not taken anything off. Let's say you want to remove a certain thing from your display. You can just go the group it's in, main. No. I've been using DisplayIO group, which is the name of my group. Dot remove, and I think you could just pass your thing. So let's say shape TG, just remove it. So it's no longer in the group, which means it's no longer going to be showing on the display. And I'm actually just going to blow that whole shape away and make a new one. So let's do shape equals none. Shape TG equals none. I don't know if this is like necessary, but I'm just trying to make it clear that I'm setting these back to empty and we're starting over. So shape equals a new shape. We gave it X and Y, so I'm gonna choose something smaller. Let's say, because I don't remember exactly how the mirroring works. So we're gonna play with mirroring a little bit. I'm gonna say 80-80. No, I'm gonna say 80-40? 80-60. Say 80-60. And I'm gonna say, what is it? Mirror. I'm gonna turn mirror X on. Let's start with just one and then we'll do two next. Mirror X true. Okay, there's our shape. I'll use the same palette. We can just reuse the palette. So we can go shape tile grid equals a new tile grid. We give it our shape. We give it our pixel shader, which was shape palette. It is, and now we need to add it back to the display. Pinned shape TG. Oops. There we go. Okay, now we have our new shape on. Okay, and this is partially telling me how the mirror works. So we made our shape 80-80, well, 80 pixels wide, and it is not quite 100, which makes sense. This bitmap here was 100. So we get the real size, and the mirroring comes into play with the boundary, I think. Shape, so set boundary. Let's do 1. Let's move it, actually. Let's move it. Shape TGX equals 120. Move it over there. Now let's do shape set boundary 1. And let's do 0, 10. Yeah. Let's do a couple more so you can see what it drew. And I did 1, I should have maybe started on 0. I'll do a couple more. I'm just doing more in the Y direction so it's a little thicker on the screen there. But basically what this is doing now, so same thing we did before. We're defining the section that's going to be the foreground. So the start of the foreground is going to be 0. The end of the foreground is going to be 10, pixel number 10, in from the side right here. But this time, there is something different. We declared it from 0 to 10, but because we have, where's it at? Mirror X, wherever it is. Mirror X right here. Because we set mirror X true, it also applies over here. And so this allows you to kind of cut corners, essentially. Not in the sense that it, well, also kind of in the sense that it helps you do something more easily, but, you know, this allows you to kind of sort of snowflake your design. Like, you know how you fold up a sheet of paper a bunch of times, and then you cut, like, along the folds, and then you unfold it, and you get, you know, the rough shape that you cut out gets rotated all around the resulting full shape, the snowflake that you cut out. This is another way that I kind of think of the shape. When you turn on the mirrors like this, you know, you're cutting out a small section, or you're cutting out a section, and the section that you're cutting out is getting, you know, mirrored across different ways. So it's almost like you're cutting out of a folded sheet of paper, and then the resulting thing that you see on the screen is the unfolded version. So, you know, we cut out this section here, we kind of imagine this shape here folded in half, you know, hamburger style, so it's folded like sideways down this center line. You know, we cut out like a little down snippet here, and then all the way over here to the center of our fold, basically. And then we unfolded it, and now we're left with this blue cutout part, and then of course the red part, which is what is left of our paper. So folding paper, cutting the edge of it, that's another way that I think of this DisplayIO shape object. Especially when you use mirror values. Before you turn on like mirror X or mirror Y, it's not as much as, you know, of the whole like folding paper and cutting section out. It's still kind of like an unfolded sheet and you're cutting out, maybe you can think of it that way. But once you turn mirror X or mirror Y on, then it's like you have folded up a paper and you're cutting the edge, and it's affecting both sides. So let's make one with both mirror X and mirror Y. So I'll remove it again, which we could actually just go up since we named everything all the same. Oh, it keeps only a certain number, I guess. So we can't just go up. Shape TG. Okay, we'll make new ones again. Okay. I'll do it again, same size, 8060. Okay. I'm gonna, let's see, let's make a tile grid. I'm gonna move it before I add it, which is totally fine as well. I have my shape tile grid already. It's not visible on the screen, but it's like ready to go. It's an object that we could add to the screen at any time. And we can actually do this, shape.tg.x equals 120. So, you know, even though it's not actually on the screen, we just moved it, you know, logically over to here. Y 50. And now let's add it. So DisplayIO group, which is what the name of our group is, append tile grid. There it is. So now let's look at the boundary when we have both mirrors on. So shape, set boundary, do 0. And let's just stick with the corner again. So let's do 0 to 10. Okay, and so it's tough to see maybe, but what we got this time is the same thing we got before, but also it got copied to the bottom now as well. Previously we were just along one fold, it copied what we did from the left to the right. Now it copies, you know, both the left and the right down to the top and bottom corners as well. We can make our little thicker section like we did before. That's going to fill that in. And we can actually do a for loop. We can say for I in range, let's just call it 10. Shape.set boundary. Let's say 4 plus I. 0, 10 plus I. Not sure exactly what that'll do. See, this is one of the fun kinds of things. I think there's room for expanding upon this snowflake idea. I think it might be a fun exercise to make, you know, black background and white shapes, and then use these boundaries to like cut out snowflakes. Not sure exactly how this one is going to come out. Okay, there we go. Interesting. So because we added I to our second X value there, you know, it brought the range in towards the right, got a larger X value, and then of course, because we have mirror, it mirrored it to there, and it mirrored it to there and there. So, you know, you can kind of see how, like, you can use the shape to make relatively complex things. This is certainly still not the most complex geometry there is. Geometry there is. But, you know, if you were sitting down to draw this with a bitmap, like, you have a fair amount of work on your hands, like figuring out the angles and, you know, drawing different bitmaps of different colors, or one bitmap with different pixels or something. You have a fair amount of work, whereas, you know, we didn't do that much work here, and we were able to achieve a similar kind of thing. Hey Keith, how's it going? Was the storm bad news, or did not do too much? It was not too bad, I will say, knocking on wood. We got a fair amount of snow. We got probably, I would say maybe like 6 or 8 inches of snow. Got a pretty good chunk of snow. But it was pretty much just yesterday, and it kind of cleared up by the end of yesterday, and yeah, I have no complaints really. The road crews came by, so our road is pretty much clear today. We cleared our driveway yesterday with the shovels, and the driveway pretty much remelted and then dried out today, so pretty good. There's still a fair amount of snow in the yard. You know, anywhere that's not the streets, basically, there's a fair amount of snow still. But not too bad at all. Yeah. Yeah, I'm waiting for it. We haven't had one, you know, a bad one yet this year. Usually we have 1 or 2 days each winter where it's like, you know, you're definitely snowed in. Like, it would have been rough trying to go somewhere the day that it was snowing. Guess that was yesterday. But by today, it's like, no problem. We can drive anywhere we need to today. There are usually 1 or 2 days a winter. It's like you're snowed in. Like, unless you have a special, you know, a special kind of vehicle, a truck or something with winter tires or something, you're not really going anywhere very safely for a couple of days. You know, 3-4 days, maybe even a week if it gets really bad. We haven't had that yet, so that's nice. Let's just, we're range 10. Let's kind of make this a little funkier. Let's make it angle back out the other way. Out. So this is kind of a fun thing to do, where, like, I haven't used shape a whole lot, so I can kind of picture what I want it to do, but I don't just know the exact way to do it. And on the opposite side of the coin, I can kind of just plug values in and play with it. And it's kind of fun to, like, do that. Just plug values in and see how it comes out. So I'm choosing 14, and that's because I started on 4 last time and I did all the way to 10. Well, I did 10 up to 10 plus 4, which is 14. So actually I want to start on 15, I think. Plus I. And then I want to do 0 again. 10 minus I? Minus I? 20 minus I? I want to do 20 minus I, actually. Ooh. Okay, that's close to what I was expecting. I was off by 1 with my Y value, though. So let's fill in that line shape. So would that be 14? I have no idea what it would be. Let's say 0. Well, it would be would have been the first one. 20 minus 0, so it would have been 20. Yeah. Okay. We have an extra one in there, but so that's kind of an interesting shape. You know what else you could do with shape that would be kind of fun is you could make like a pottery. I had this pottery simulator on a tablet one time where it would show like a rough, a clay blob, and you could kind of touch, and it was like as if the thing was spinning. Like as you touch, it would kind of add and remove regions, kind of like how we're cutting out here. The top of this thing reminds me of the top of a pottery pot, like that you would spin on a spinning wheel. Pottery wheel? I don't know the right name for it. That might be a fun program to make, though. You kind of like touch and it molds the boundaries of the shapes to more inwards and outwards. It could be kind of fun. Okay. Let's see. I think that's probably good for playing with shape for a while. I'm basically just playing around with different stuff today, Keith. I don't know exactly when you joined. I assume you didn't see the whole thing there, but basically we're showing off the PR that I started working on the other night, which was this thing K-Match did to be able to split the REPL and the DisplayIO. So we got that pulled up, and I'm just kind of like playing around with the REPL. It's been like basics of DisplayIO, but also just kind of playing around, exploring how stuff looks on this, and playing around a lot of it. I want to eventually, I think, make a just up on a moment ago. Yeah, touch and shapes I think would be fun. Ultimately, I want to, I think, make some content, probably videos geared around DisplayIO. I can imagine a couple of different formats for them, but the basics of DisplayIO, but even maybe diving deeper into certain things, maybe a video dedicated to the display text label and all the things it can do, maybe videos dedicated to some of the widgets that we've created or the layouts and stuff like that. So part of what I'm doing here today is just exploring some of those different aspects and seeing, what kind of things make sense to show in a starter video and how they work and all of that stuff. This is also the first time for me for a lot of this stuff actually just coding from scratch all of these things. Very frequently I'll go to a simple test and I'll copy and start from there, and I've actually just been coding from the ground up, which is kind of a fun way to change it up, kind of make sure I actually know the way that all these things work. I do have a dark doc somewhere though. Where's that? Let's see, is there anything else we can do with shape? I think that's pretty much it for shape. Shape is it's a fun thing. It can do quite a lot of, you could imagine how you can achieve a lot of different looking designs, but in terms of an object, it's actually fairly simple. You create it and then you set the boundaries, and that's really all you do to it. Can you change mirror X after the fact? If not, that would be a good low-hanging fruit to try to add to the core. Unless there's like some mega complex reason why it can't work, but can I just go mirror X equals false? No, can't change it. Has no attribute. So you set it in the constructor, but you can't change it after the fact. That might be interesting. We might look into, in fact, actually, I'm going to indulge a quick rabbit hole. We're going to go look in the core at the code for shape and see if it would be reasonably possible to expose that as a property. It's really neither here nor there. Doesn't matter too much. We could just make a new one if we needed to, but I'm kind of curious. Let's go. We'd be looking here. Let's actually look in bindings first. DisplayIO shape. New. There's our set boundary function. And of course this is in bindings, so this is not the function itself, not the logic for it, but this is like taking the arguments and making sure they're the right type, and then ultimately passing them to a function that will do the actual work. And I will say it's going to be a bit slower for me looking at C code than it is Python code, certainly, so bear with me a bit here while I get pixel. Does that exist? That's not in the docs, is it? Can I call that? Get pixel? XY? Shape.get. Is there an underscore? Get pixel? Yeah. Pixel. 5. No. Oh. Well. No, yeah, that's look like it. You went 32. Get pixel. So this is in shape.h. Does this get pixel? So shape.c doesn't have it. It has set boundary. Interesting. So I think this code, well, maybe there's not even code for it. I guess this is just the header. And it's only declared in H and not C. Let's head back to module. Whoa. Whoa. That's my music. Try to like go back to it and pause and unpause real quick, because occasionally it does the like, are you still watching us, trying to cut, you know, bump my timer or whatever. Now it decided to shoot itself onto this screen though. In here. Here, get pixel in here. Let me put this on. There's a get pixel in here. Huh. So we could. So this is like not exposed. This function exists, but we can't call it from actual CircuitPython land. I wonder if it's used from C somewhere, or if it just. Well, we would find it, I guess, right? It's not used anywhere in here. Interesting. So it's opposite in module. In shared bindings, it's declared in the H file, but not in the C file. But in shared module, it's backwards. It's implemented, I guess. Not really declared exactly, but I guess declared also. But it's implemented in the C file, and it doesn't exist in H file. Although get boundary doesn't exist in the H file. Set boundary. So it doesn't exist in the H file. I'm still not 100% up on, I guess, knowing where everything should and shouldn't be. I would have thought the set boundary would have needed to be declared here as well, but I guess not. It is in the C though, I'm sure, right? Set boundary? Yeah. Along with get pixel. It's just get pixel doesn't actually get used. So if we wanted to actually be able to call getPixel, we would need to put it into here. Shape C. And we would need to do this kind of stuff, like get its arguments and make sure they're ints. And then we would be able to call CommonHal DisplayIO shape getPixel, which is declared here, after we got the arguments. I think the rest, the second half of that rabbit hole will be for a different day, maybe. But that does seem like a fun thing to do, is hook that up and then be able to check on the pixels, basically. So we could arbitrarily choose a pixel and know whether it's, in this case, red or blue, but really if it's index 1 or index 0. Which could be helpful for the pottery thing, actually. So maybe the like, Adafruit is often thinking of the project first. Like, what is the project that uses the feature? A lot of times it's not necessarily like, hey, let's make this new feature in CircuitPython, but a lot more times it's like, we have this project in mind. Let's go make the features that it needs. So in this case, the project is the clay thing. The feature is the getPixel. The reason why that'd be helpful is if you touch in the pot that you're spinning and pull outwards, the pot should get bigger. It's like you're smearing it outwards to make it bigger. But if you touch in the outside, in the red in this case, pull it inwards, then the pot should get smaller. So being able to know which color you touched, whether it's foreground or background, we would need, I think, to make the pot thing how I'm imagining it. So maybe that'll be a feature stream. We could implement that in the core and then build what I'm imagining for this pot dragging clay thing. What else do I want to play with tonight, though? We did shape and bitmap. Might not do too much more tonight. This is all tile grid. We barely scratched the surface of tile grid. So far, we've only used tile grid to tie together a bitmap and a palette. But tile grid actually has a whole other superpower that I haven't even talked about. I'll show you in the Learn Guide, but I think I'll save actually messing around with it for another day. Tile grid. So tile grid can do this whole other thing where it can basically split up a sprite sheet into a series of swatches, or tiles as they're called. And each tile is given an index, and then you have another grid where you can plug in the indexes and basically pull from one sprite sheet and plop that tile into another section, into another grid. Which here they're illustrating with these flower pictures. You know, this is our source bitmap, and it's divided into this 4x3 tile grid. And so we're taking the tiles from here and then applying them into this 2x2 tile grid. And so in this case, tile 9, which is this one, we stuck it in the top left corner. Tile 5, which is this one, we stuck it in the top right corner here. Tile 3, which is this one, put it in the bottom left. Tile 0, and our source is the top left, we moved it into the bottom right. So tile grid also has this whole other concept here, which we didn't touch at all on in my stream. We didn't play with this at all. We used tile grids twice, but only for connecting bitmaps and shapes to palettes. But tile grids also facilitate this whole sprite sheet behavior, which is really cool. Another good page for learning about this is multiple tile grids right here. This is a more practical use of tile grids. The flower image does show the practical functionality of it, but this actually makes more sense as you know, why you would want to do that, how it's more powerful. This is like the basics of a tile map. So you have a sprite sheet, you know, you have a tile grid that you're filling in, and you're able to fill in indexes that match. So we can make a big floor in the middle with 7s, because that's the, you know, center floor. You can build out walls with 6s and 4s and 8s and 10s. And there's corners as well. So when you fill it all together, you can make a bigger image than what your sprite sheet started as, right? You started as just these 12 sprites, but you can kind of reuse them, copy paste, rubber stamp them into a bigger grid. So this is like the core logic behind tile map games, which there's also a guide in here. Guide that I made was for tile map games that's in the Learn system. But that, I think, is all different stuff for a different day. So we took a short tour through Bitmap Tools. We played with bitmaps. We played with shapes. I didn't do on-disk bitmap. I don't know if I have an image just ready to go. I think maybe one more thing I'll do is let's get some labels into the mix and play with those for a minute, and then I'll probably call it a night for now. So let's head back to here. Yeah, tile grid is it can do some crazy cool stuff. It's almost like this dual-sided thing. I think of it as like, you know, you think of it normally people interact with it this way, like in this code where they're basically just attaching it to a bitmap or a shape. In my case, although bitmap is probably a lot more common, attaching that to a palette. But that whole sprite sheet rubber stamp behavior is like a whole other can of worms that tile grid also facilitates. It's a really cool functionality. So let's make a label. Let's get rid of our bitmap that we have, our pink one with our diamond there. DisplayIO group dot remove. I think we just called it bitmap. Object not in sequence. We must not have called it bitmap. Let's try checking what it is. DisplayIO group. Let's look up the thing at index 0, which is group. 1 is a tile grid. 2 is a tile grid. Oh, well, duh. Yeah, we called remove on the bitmap, but it really should be the bitmap tile grid, which I guess, I don't know if we called it bitmap TG, or did I just call it tile grid, I think? Tile grid. So this is what we really want. DisplayIO group, remove, tile grid. There, it's gone. Let's remove the shape too. Nah, you know what, let's leave the shape. Shape's kind of cool. Let's make a label. In order to do that, we need to import. So I'm gonna go from Adafruit, display, text, import, nope, dot. I'm gonna put dot bitmap label, bitmap label, import label. Got it. I'm gonna call it LBL label equals a new label. I forgot a terminal IO font. We need a font, so we have to declare a font. Import terminal IO. This is the built-in font. Label equals label. Font goes first. Terminal IO dot font. We don't actually need anything else. That's the bare minimum we can have for a label. So we made a label. We can add it to the display. Right now it's not showing technically. Group. Got append. Label. Okay, so now it's technically showing, but the thing is we don't see anything about it. We don't see it anywhere, which that's because it doesn't have any text in it yet. It's a label, but it has no size. There's nothing in it. So if we said label text equals hello world, now we can see kind of our text appeared. The bottom half of our text appeared, which this tells us one of the key attributes of label is that it is it's not placed from the top left by default with its XYs. If you set it by XY, the origin point is in the center on the left. So that's why we're halfway off the screen. The other half of our label is actually above the screen up here. If we move it down, label.y equals 10, then it will move down some and be on the screen. If you don't want to bother with the halfway point though, so it starts up here defaulted to 0, halfway off the screen, the other thing you can do is use the anchor point and the anchor position. So label.anchor point equals 0, 0. So this is setting the anchor point to be the top left of the label. Now we can go label anchored position, and we can set the location relative to the anchor point. So relative to the top left, which is what we set it there with 0, 0. So here we could now say 0, 0 as well. This is 0, 0 pixels on the display. And this will now set it so that the top left corner of the label is at the top left corner of the display, which means that it is actually showing the full thing. Let's say we wanted to put it in the middle of the display. That's a pretty common thing you might want to do for your user interface is have some text be center aligned. You can achieve that with anchor point and anchored position. So anchor point equals 0.5. 0.5. Actually, let's keep the y value at 1. So this is the x anchor point and the y anchor point. And the anchor point itself is actually a percentage, essentially. 0.5 here means 50% of the width, which happens to be the middle of the thing. So that says we want our anchor point to be the middle on the top. So we'll set that. Now you can see it moved, and that's because our anchor position is still set to 0, 0. So it moved that center point on the top to be 0, 0. So if we want it in the center of the display, though, what we do is we go label.anchored position equals, and now we can say we need the center of the display, so we go, in our case, we have board.display.width, lowercase width, we can divide it by 2. And then for our y, let's just set it to 10. Here we go. Now hello world is centered within the display. Our box here, our red and blue thing, is off to one side, which kind of makes it feel heavy one way towards the other, but our label at this point is actually in the center of the display. Really good to know. I'll need to remember anchor point and anchor position. Yeah, I really, really like anchor point and anchor position. In fact, we took that logic and we put it into the generic widget class, which is in DisplayIO layout, in order for making new widgets. And if you extend widget, then you get this anchor point, anchor position behavior in all your widgets. Label was the first place where it existed, but we've moved it into there, and lots of other widgets can be placed this way now, so it's really nice. Let's say you want it anchored to the right, though, and continuing with the anchor points and things. We put it in the left, we put it in the center. Let's say we wanted to anchor it to the right. So let's go label.anchor point equals, this time we'll do 1.0 on the x, and I'll do 0 again, so top on the y. And so right away we see it moves, and that's because we're now anchored to the far right edge of our label. So at this point what we have is the far right edge of our label is in the center of our screen. So let's move it, though, to where it's anchored towards the right edge of our display. We can go label.anchored position equals, and this time we could go board.display dot width, and we could just go like -4, let's say, just give it a little bit of padding there on the far right edge. Whoops. Oh, right, we need to set two things. So I set the X, and we also need the Y. I'll just call it, let's say that's 4 also. There we go. So now we're anchored into the top right corner. And you can anchor onto the bottom edge of the display as well, although at this point, because of the way we're split here, I don't think we can easily anchor it to the bottom of this. We could hard code it and it would work. But one thing that doesn't exist is like groups don't have a size. So I can't say DisplayIO group dot height doesn't exist. But that would be cool if that would give me the height of this group, but I think a group does not, it's just a collection of other things. All of those things happen to fit within a rectangle of bounds, but rectangle of bounds is not necessarily really part of the group concept. So it would be tough. We'd have to just hard code the size here. We happen to know is like half the display, so we could still do it by the display, but just divide it by 2. Let's say we wanted to have scrolling text. I made a certain kind of scrolling text for the Winamp project, but this is a different kind of scrolling text. Let's say we just want this hello world to like scroll all the way across the display here. We could go while, I'm just gonna make, am I gonna regret an infinite loop? Let's see, let's go while true. Yeah, I already kind of, it's actually just valid syntax, okay. Let's go y equals, no, let's actually go y equals label dot, no, and really I want x. X equals label dot x. What is x right now? 170. Let's go while true, label dot x, new x equals label dot x minus 1. If new x less than 0, new x equal board.display.width minus 1. So scooting to the left by 1 pixel each time, or well, we're trying to. We're checking the left pixel. If we made it past 0, then we go all the way back to the right edge of the display. So we have a new x, and then let's go label.x equals new x. And I probably should have imported time before now, because we should probably time.sleep some, otherwise this is going to go way too fast. Let's let it run. Yeah, so it's so fast that it doesn't actually look like it's moving only to the left. Let's keyboard interrupt that. Let's import time. And let's try once more. All the same stuff. But after we update it, let's go time.sleep by, doesn't even need to be much. Maybe a little more than that. Okay, maybe not so much, but a little faster would be better. But now we have this label which will scoot itself across the screen there. Once it hits the left edge, it'll restart all the way back over at the right edge. And we could also lower this. We could say instead of 0, if we wanted it to run all the way off, we could say if new x is less than 0 minus label.width, or just negative label.width. I won't do it for now, though, because I have to redo all these lines one by one. But that's the basics of how you can make a scrolling label. What we did in the Winamp was a little bit different. We had a static box that didn't move. We scooted the characters over by 1 each time. Anyway, I think I'm going to head out for now, though. This has been fun. Huge thank you to KMatch, again, who is the person that made our little split screen thing that we are playing with today. I think this is a really, really super neat new feature. I think it's going to be really helpful to be able to make future, tutorial style, how-to style content around DisplayIO. Kind of doing a lot of the same sort of stuff I was doing tonight. I mostly was not very focused, just kind of wandering around, playing with whatever I felt like tonight. I think we'll hone it. We'll figure out what are the most important things to show the average user starting out with DisplayIO, and I think we have a really neat way to create some how-to content using the split screen approach, so that you can see both the code commands as I run them and the output on the display. I will mention as well, while we're talking about the split screen thing, the other part of this that would be really, really super cool is eventually if we get USB host mode, then we could have like a keyboard plugged in, and your bottom half could be like an interactive shell where you type on the keyboard, not connected to the PC, but connected directly to the CircuitPython device. So then you have like an all-in-one little DisplayIO development platform on your PyPortal, which I think would be really, really super neat. And this gets us one step closer to there. So thanks to KMatch for this PR. Thank you to everybody who watched. Keith, let's see who else was around earlier. Cedar Grove was around. Toaster Fuel reminded me to make some delicious cookies, which I do need to do. So thank you to all the folks that watch, and yeah, I'll catch you all next time. Next Saturday morning probably is my next planned stream, at least. So, yep, I'll see you then.